So section 10.3 is all about analyzing graphs and what you can get out of a graph. And section 10.4 is about translations. So we're going to kind of review those two topics right now. I'm going to look at this first graph. This first graph looks like a square root function, except that I know that the square root function always starts at 0, 0. So it's the square root function, but it has been translated. So it's like the square root function with a translation. From a graph, I should be able to tell what the domain is from the graph. I should be able to tell what the range is. Now, the way we do domain is we look at the x, all the possible x coordinates. So the furthest left-hand point is at 2, and then all of these x coordinates are possible past all the way out to infinity. We're assuming that this graph continues on as it just goes off the page. So the domain, starting to the left, is going to be 2, and to the right is going to be infinity. Domain always goes left to right. Now if we do the range for this function, our lowest point for the graph is at 0, and it goes all the way up to infinity. So the range for this function is from 0 to infinity, because if I go low to high, my lowest point is at 0 and goes up to infinity. I should also be able to tell by looking at a graph what the end behavior for the graph is. Graphs only have two ends, and this particular graph, since it starts here and has a starting point, does not have a left end behavior, but it does have a right end behavior. So for this graph, as x goes to infinity, we will not ask you to write this whole statement out yourself, but you will be expected to complete it. So you'd be expected to complete something like this. As x goes to infinity, that's the right side of my graph. My y coordinates are getting bigger and bigger towards positive infinity. My arrow points upward, continuing towards infinity. I should also be able to tell whether a graph has an axis of symmetry. This particular graph has no axis of symmetry because I can't fold this graph in half anywhere and have it land on top of itself. So this graph does not have an axis of symmetry. Now, as far as translations go, I know that this is a graph of the square root function. So the oops, that's too fat. Oh, that's right. So the original square root function looks like this, and that's the one that starts at 0 and continues up. But this one has been translated. It's been translated 2 to the right. So a horizontal translation is going to be attached to the x coordinate. So our new function, the function that's graphed here in red, is going to be the square root of x minus 2, because horizontal translations are always attached to the x, and they always have the opposite sign of what we think. All right. The next function is an absolute value function. We should be able to tell by looking at the graph without even knowing that this is an absolute value function. We should be able to tell the domain and range. So the domain, the furthest left-hand point goes off the graph, so starts from negative infinity, and the furthest right-hand point goes off the graph. So the domain is going to be all real numbers all the way off the graph in both directions for my domain. The range, the lowest point is here at -1. And there is a value there, so I use a bracket because there is a value there. And then the highest point is all the way up to the sky. So the range goes from -1 to infinity. This graph has two ends, so it has two end behaviors. The end behavior as x goes to infinity. This graph is pointing up to the sky as x goes to infinity, so f of x approaches infinity as x goes to infinity. So the right-hand end behavior is positive infinity, and then the left-hand end behavior as x goes to negative infinity, so this end, that arrow is pointing up, so our function also goes to infinity. This function does have an axis of symmetry. It's off the graph, remember, so it doesn't look totally symmetrical in the part that we see, but if we fold this graph, because we know it keeps going, if we fold it on the line, we have an axis of symmetry, and it is x equals negative 2. We also know that this is the absolute value function because that's the one that's v-shaped. The standard absolute value function goes through the origin, but this one has been translated. So if I go to the translations for this graph, the original function, the parent function, would be absolute value of x, but our function has been translated to left and 1 down. So the equation for our function would be absolute value of x plus 2 minus 1, because our graph is going down 1 and left 2. The horizontal translation gets attached to the x, and the vertical translation gets added on to the end. I wanted to do one more graph because this is this one is a little bit different, I guess. So this one, if I want to start with domain and range, the domain, our left-hand arrow our side of the graph continues, our right-hand side of the graph continues, so the domain is going to be negative infinity to infinity. Sometimes we also write that as all real numbers. It's the same idea. Our range starts at negative 3, but it doesn't actually hit negative 3. It's getting closer and closer to negative 3. So our range is not going to start with a bracket, it's going to start with a parentheses. Oops, negative 3. Our lowest point is very, very close to negative 3 without actually being there. And our highest point is shooting up to infinity, so our range is going to be negative 3 to infinity. There is no axis of symmetry for this graph because I can't fold this graph in half and create and have it land on top of itself. So there's no axis of symmetry here. There is end behavior though. As x goes to infinity, so the right end of this graph is pointing up to the sky. So the end behavior to the right is going to be positive infinity. To the left, this arrow is not pointing down or up, it's just pointing sideways. So as x goes to negative infinity, f of x is not going to infinity, it's not going to negative infinity, it's actually flattening out and going to negative 3. We talked about if that's happening to you, that means that you have an asymptote at negative 3. Our end behavior is negative 3. We have an asymptote there. This is an exponential function, and I notice that if I translate every single point on this graph up exactly 2, I wind up with kind of a doubling behavior. So this, exactly 3, I'm going to translate up, So if I move this point up 3, and I move this point up 3, and I move this point up 3, I'd be at 4. So I have 1, 2, 4, and so this graph would be the original graph. That's the 2 to the x graph. So if our original function, was 2 to the x, our translation is taking that 3 units down. Sorry, the original is going down 3 units. So our new function, our translation, is down 3. So that's not going to be attached to the x because it's a down motion. So our new function would be g of x is equal to 2 to the x minus 3. So these sections are getting at understanding graphs and also understanding those translations. So this is a review of that. Good luck today.